Okay, first hour Algebra 2. This should be Tuesday the 21st. And good morning to you, or afternoon, or evening, whenever you're watching this. And just a little info for you. When you turn those pictures in, I'm doing my best to give you a little feedback on them. It might simply be, hey, they're all good, okay. But I figured out how to use my iPad to kind of mark on them to kind of show you maybe if you went wrong on one where they went wrong. So do check the return, when I return the homework to you, do check, take a look at it and see if I put any comments on there. Okay. All right. Last week we looked at arithmetic sequences where we added or subtracted our way across our list. Today we're going to look at geometric, which is when you multiply or divide. Okay. That's the difference between arithmetic and geometric. Now the difference between adding and subtracting, which is arithmetic, and multiplying or dividing, which is geometric, is that the geometrics will get bigger or smaller a lot faster than the arithmetic, and you'll see that today. Okay, so we're going to try to just simply today explore the ins and the outs of what a geometric sequence is. So we look at number one here, and we scan our list, and we look again like we did last week, look from one term to the next, figure out what's going on. What are we doing all the way across there? Well, we're multiplying by 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 48. Or excuse me, 12 times 2 is 24. 24 times 2 is 48. So we continue. We times by 2 again, we'll get 96. Times by 2 again, we'll get 192. Times by 2 again, we'll get 384. So there's the next 3 numbers in that list. Now, this number that we multiply by in a geometric sequence, that is called the common ratio. And it gets the variable r. All right. Now the surefire way to find your r is you take any number in your list and you divide it by the number in front of it. Remember last week to find d, we could take any number in our list and subtract the number in front of it. For our geometric, we have to divide. So in our list, if we look at a couple combinations of those, we could have done 6 divided by 3. We could have done 12 divided by 6. We could have done 24 divided by 12. Each one of them will give us that positive 2 that we multiplied by. Okay? So let me clear off a little space here. So that's how you find r. You can take any number in your list and divide it by the number in front. Keep that in mind. Now, last week we explored how many times we would multiply to get to a certain number, like a sub 6 here, or the 6 here, excuse me, is a sub 2. That 2 is important. That tells us it's the second number in line. How many 2's do we multiply by to get to the second number in line? We multiply by 1, 2. Okay? So we times by 2 one time. The third number in line is this 12. How many 2's do we multiply by to get to 12? Now again, we're saying that we're always going to start at the 3. So starting at 3, how many times do we multiply by 2? We multiply by 2 times. And even if we go all the way out here, let's go to our last one. Our last one is the 8th number in this list. So the 8th number was 384. Well, how many times did you multiply by 2 to get to that 8th number? 7 times. And we see that there's this relationship that's always 1 less than how many times we multiply by. Okay? Or how many times we multiply is always 1 less than the position. So if we wanted to go out here, let's just say we're going to go out here to find the 35th number in line. What will you tell me about how many times will you multiply by 2 to get to the 35th number? You'll multiply by 2 34 times. We should be able to figure that out just by what position we're in. It's always 1 less. You just simply subtract 1. Okay? So if we look at the rule for finding a mystery number way out here in our list, let's call it a sub n. So what position is this in? It's in the nth position. Okay? How would we get to that number? We would say, we got to go, I'm going to draw all over this now. We would say we have to start at the first number, 3, and then do whatever we got to do, which is multiply by 2. Now, how many times will we multiply by 2? And remember, when you multiply by the same number a bunch of times, we don't write 2 times 2 times 2. We write that as 2 to the third power, so we create an exponent. Well, what would our exponent be up here? It would have to have this relationship where whatever this position is in, it would have to be 1 less than that. So the rule would be, for this sequence, 3 times 2 to the n minus 1, and usually you put little parentheses around your 2 just to make it look a little cleaner. Let me rewrite that. You would say times 2. Well, hold on, you wouldn't need that times. 3 times 2 to the n minus 1 power. Safe way to write that. Okay? Now, I really want us to get a grasp on how to write this rule this week. We had a little bit of trouble with that last week, okay? So that's one of the things we're going to do today. All we're going to do today is find the next 3 terms in our list, so we got to figure out what we're doing, and we're going to write the rule, okay? Now, one thing that can happen with geometric sequences that won't happen with arithmetic sequences from last week is, look at what's happening to this list. It's the exact same numbers, only they alternate. So it goes positive number, negative number, and so on. Okay? So what number are we multiplying by there? Can you think about it? I'll give you a second. Well, we could do the surefire way to figure it out. We could take any number in our line, like our -6, and divide by the number in front. We're multiplying by -2. Okay, now let me clear this off. I'll show you what happens. So when you do 3 times -2, you get a negative answer of 6. But when you do -6 times -2, you got the double negative going on. Negative times negative gives you a positive. And then when you have 12 times -2, you have a positive times a negative, you get a negative answer. So that's why how it alternates back and forth between positive and negative. So the next number in line would be 48 times -2, would be -96. Then the next number would be -96 times a -2. You'd have a double negative going, and you'd have a positive 192. And then multiply by -2 again, and we get -384. And we have positive, negative, positive, negative, positive, negative, positive, negative, all the way across. Okay? But how would we write the rule? Let's say we wanted to go way out here to some mystery number. It's so far out there we don't even know what position it's in. So we say it's a sub n. What's the number, or how do we get to that number there? We don't want to know exactly what the number was, but how do we get to it? We would say you got to start back here at your first number, 3. So we start at 3. And then you got to do whatever you're doing. Well, what are we doing? That's our r value. We're multiplying by -2. And when that's a negative, you definitely want parentheses around it. Then, how many times do you multiply? Well, whatever that number is there in, it's going to be 1 less. And there's our rule for this sequence. Okay? A couple more examples. Page down. What's going on here? Okay, so it looks like you got a problem with number 3. You're not going to get number 3. Number 4, let's go skip to number 4. You can try number 3. I'll tell you what the answers are. If you looked at my notes on the attachment. Okay, let's jump to number 4 then. What are we doing to get from one term to the next? That's that r value. Well, we can simply take -40 divided by 4. We are multiplying by -10. So that's why it went from a +4 to a -40. And then we multiply by -10 again, it jumps back to +400. Then it jumps to -4,000. Then the next one would be a +40,000. Then a -400,000. And when you multiply by 10, you're just adding a 0 on the back. And the last one is +4 million. Okay. Now, if we wanted to continue on and find the mystery number out here, how do we do it? We would have to start at the first number. It's like you're giving directions somewhere. You got to tell a person where you're starting at. And then what do they do? Well, you start multiplying by -10, and you would multiply -1 time, n minus 1 times. So there's the rule for this one. Okay, I don't know what happened on number 3, but on number 3, if you copied the notes down, the 3 fill-ins were 1,280. 5,120 and 20,480. Those were the three fill-in numbers. The rule would have been 5 times 4 to the n minus 1. Okay, and you can really see here on number 4 how the numbers get big in a hurry. That's why on that lottery problem from yesterday, the second option was the most lucrative option. You just had to have some patience. So I'll look at that and see how many of you chose the second option. That would have been the one to go with. Neither one of them will be bad. Who would throw away $3 million from option 1? But option 2 was the more greedy option, I guess is the way to say it. Okay, so for on your homework, find the 3 missing terms, figure out what you're multiplying by, and find those 3 missing terms and write the rule. Okay, we'll see you tomorrow.